This is your instructor, Joe Johnson, and we're going to cover Lesson 14 today, Troubleshooting and Support. The objectives for this chapter, the things that you should be able to do after you successfully complete this chapter are: describe the benefits of documenting a network and list what elements should be documented, list the steps of the problem-solving process, explain different approaches to network troubleshooting, make use of problem-solving resources, describe network troubleshooting tools, summarize common trouble situations, and describe disaster recovery procedures. The following is a list of some reasons network documentation is good. All right? So the first step before you do anything is you should document your network. So we're taking this class is networking and security. When you develop a network, you should always document it. When you document it, you set a baseline for your network. You say how your network should be run, so that if something gets modified, changed, or taken away from the network, we can tell that a change has occurred. When we have documentation for our network, it makes equipment moves, adds, and changes easier, because we can plan ahead. Since we know exactly what we have, we can sketch out some changes. Maybe we might be adding another switch or another router. If we have a documentation in a network, it's a lot easier to plan. It provides needed information for troubleshooting. If you have no idea how your network is set up, how do you know how it should work? Remember, this baseline or this documentation is going to show you how your network is intended to work. It offers justification for additional staff or equipment. So when you turn in your budget request, you can say this is what we have and this is why we need it. When you start operating within standards or certain protocols, like maybe you're trying to certify your network as being secure, it's going to help the auditors determine whether you're in compliance or not. For instance, PCI DSS is a standard for processing credit cards. So we have to have certain safeguards in place to be able to process credit cards according to the PCI DSS standard. If we have documentation, we can easily show that we are compliant with the standard and we can continue processing credit cards. It supplies proof that your installations meet hardware or software requirements. So if you are a contractor and you were hired to come in and create a network, typically you're going to have a list of requirements before you start designing the network. When you have documentation after your project, you can show your client that you met all of their requirements. It reduces training requirements. When someone new comes on board, I don't have to train them about how the network is set up. I can hand them a book and say, this is how our network is set up. They can read the book and we'll transfer the information that way instead of having to walk around and train somebody. That takes a lot of time training. It facilitates security management. So if I'm trying to secure the network, it really helps me to know how the network is laid out. And it improves compliance with software licensing agreements. So if we're licensed for a site license for software, maybe have 200 licenses, we can show that we only have 175 computers. So if we want to demonstrate that we are within our licensing, we can use our network documentation for that. One important component of maintaining your network and troubleshooting is change management. In a network, a change is some procedure that requires modifications to the equipment on the network. When you move a workstation, you need to know which port or patch panel and switch ports are currently being used so they can be disconnected. What we mean by that is typically we don't want to leave ports on the wall open. That's an invitation for people who are trying to break into our network to come plug in a device such as a laptop and infiltrate our network. So what we're going to do is when we move that station, we're going to turn off that wall jack so that nobody can come plug something into it. Make sense? Without proper documentation, you have to trace all of our cables. That's a big job, figuring out which port on the wall in a certain room matches the port inside of the equipment closet. Additions made to your network can happen more quickly and with less chance for errors if the documentation is up to date. Again, when your documentation is correct, you know how things should be wired, and then you can quickly determine what's not configured correctly and you can fix it. The documenting of changes in your network, which includes reasons for the change, the impact of the change, notifications, and approval procedures, is called change management. So if we have change management in place, we have a committee that approves all of our changes. We don't walk into some place and just start changing things. We have to pass it through a committee, which has 3 or 4 people, and they look at it. It's much too easy for us to overlook some impact in a change that we're making and take down the entire network. So what we want to do is we want to make sure other people's eyes have seen the change we want to make so that they can approve it, and then again, having more eyes look at it can find problems with the change a lot easier than one person looking at it. It also protects the technicians because if the change impacts the network greatly, we can point back to the change management committee and said, I passed it through these people and they said it was okay. So it kind of protects your job. So when we're troubleshooting, documentation is very important. We need to document the physical and logical addressing. So we should at least have a list of all the MAC addresses of all our devices. Okay? How the devices are connected, and data about the cabling should be documented. So the type of cable, where the cables are connected to, where the backbone of the network is, things of that nature will allow us to troubleshoot a lot easier. The reason we probably want to keep track of our physical addressing or our MAC addresses is we'll be able to identify devices that are connected to our network that don't belong to us. On the previous slide, I said we don't leave jacks open on the network. We don't leave ports open on the walls that aren't in use. If we overlook one of the ports and somebody plugs something into it, an alarm should go off on the network saying there's a device that just connected to the network that we don't recognize. That is why we need our MAC addresses documented. Accurate documentation of the MAC addresses helps quickly find issues such as conflicts and the source of the excessive traffic. When troubleshooting sessions that require protocol analysis, documentation provides the names and addresses of devices. So when I do Wireshark, when I do protocol analysis, when I'm looking at the traffic on my network, it's easy to find a device that is causing problems on the network if all of my workstations are documented. Having help desk software is important. So typically there'll be a help desk at the organization, and they'll run some kind of help desk software such as Heat or Trackit, one of those packages that keeps track of trouble tickets. Okay. So what we're going to do is, the way the IT organization is organized is we have 4 tiers to our organization. So I'm going to draw 4 layers. Okay, there's our 4 layers. If we have software that manages these trouble tickets, what's going to happen first is it's going to hit Tier 1 personnel first. So Tier 1 is going to be people at the help desk. And these are the people at the bottom of the totem. Let's see. So they're going to get paid the least. So all you do is you sit at a desk, a help desk, and you answer phone calls. Okay? You get paid a little bit of money. And what you do is, if it's a request to reset a password, then you are going to go ahead and reset that password. If it is something that you cannot handle, you're going to put, when you change the password, you're going to put it in your help desk software so that you get credit for solving the problem. But anything that comes into the help desk as a phone call, you're going to convert it to a trouble ticket. So you're going to type in what the client tells you, and then you're going to try to troubleshoot it. If you cannot troubleshoot it, you're going to escalate that trouble ticket in the trouble ticket system to tier 2. So we have a whole nother group of people that work at tier 2. So this is entry level here. You work at the help desk a little while. You start troubleshooting problems more advanced than tier 1 personnel. People go through those trouble tickets and they say, hey, he's solving problems. He's solving problems that he doesn't have to escalate up to tier 2. He's saving us money. Let's give him a promotion to tier 2 since he's doing the work already. So as you work in tier 1, you'll gain experience. And when you're good enough, you'll get promoted to tier 2, which is going to be the network administrators. The network administrators or the server administrators. They make more money. Okay. So maybe in the help desk you'll make $30,000 a year, maybe somewhere around there. Depends on where you are, what city you're in. Maybe 40, 45 for a network administrator. And these are like average salaries. So network administrator troubleshoots the network. System administrator troubleshoots all of the workstations on the network. Goes out and replaces hard drives, things of that nature. So technicians are down here. People with more troubleshooting skills are at tier 2. As you become better at tier 2, or as tickets are not resolvable by the tier 2 people, we escalate the ticket up to tier 3. Okay, and these are the engineers, so network engineers. So they know a little bit more about stuff that's going on. Right? They know about designing networks. They know about how things should be operating. They understand the actual protocols so that they know how things work. So they're not just sent out to fix stuff or to troubleshoot things. They know how to look at data and say this data doesn't look correct. So we need to figure out what's going on. So they really have an understanding of what's going on the network. Network engineers are going to make more money because they need better troubleshooting skills. And as you move up this ladder in the IT department, your instincts are going to become better and better and better about what problems are and where they're probably located. So this comes with experience. So they'll probably make about $60,000 a year. Something like that. And that's an average. The longer you work in the field, the more money you make. And then if they can't solve the problem, there's a fourth tier. And this is the top of the food chain in the IT department. Okay? And these are the architects. Network and software architects. They have programming skills. Right? So we'll just put programmers. So these are the people that can actually write new software to fix problems, things of that nature. And they make over $100,000 a year, right? Everybody knows programmers make a lot of money, but it's a specialized skill. Not everybody can do it, right? We'll just put 100 and up. They make a lot of money because the further you go up this IT department, these tiers, the less people that are there, right? Anybody can sit at the help desk and, well, most people can sit at the help desk and type a problem that comes in over the phone and escalate it up to the next tier. Most people just starting in IT can do that. Then you have a smaller group of people that can actually troubleshoot the network and do the things that a network administrator can do. And then even less people know the knowledge base that you need to be a network engineer. And even fewer people know how to program. So you go up this ladder, and as you get to the top, there's less and less people. So back to documentation. When a help desk call comes in, we're going to turn in these trouble tickets. These trouble tickets are going to get escalated through the IT department. And if I document how many trouble tickets I have and the types of trouble tickets, it justifies hiring more people. If this tier 2 person is getting hundreds of requests per week, then you can say we need to hire another network administrator. Look, we have actual tangible evidence that he's overworked. Statistics on network response time and bandwidth load as justification for upgrading servers or adding new equipment. So we can also document how much of our pipe that we're using or how fast the servers are responding to document those types of things so that we can say, hey, we need a bigger pipe, we need more bandwidth, or we need a new server because the server's being used so much that it's responding slowly. I always remember to train new employees on how to properly document additions and changes to the network. That would be like an introduction to this help desk software. And what you can do in the help desk software is require certain things. Like you can require the serial number of the computer. You can require them to put what version of operating system they're running. So that once you require things like that, you can start to build statistics on it. We also want to keep documentation on how we're complying to standards. Okay? If we don't follow standards while we're wiring, here's an example, 568A or 568B. Those are wiring standards for Ethernet cables. If both ends of the cable are either standard, they match. Like if both ends are 568A or both ends are 568B, that is called a straight-through cable. If we mix or match these, if we mix these two standards, for instance, we have one end of the cable that has the 568A standard, the other end of the cable has a 568B standard, and then that's a crossover cable. If we don't follow these standards, the people that come behind us it's going to be a nightmare troubleshooting because they're not following the standards with the colors in the wires. So where orange wire should be, there's a green wire. Where there's a blue wire, there's a brown wire. If they don't follow these standards, they just use any coloring scheme when they're creating these Ethernet cables, then the next person that comes by is going to have a really hard time troubleshooting or fixing a problem. So we need to make sure that we're following standards. Okay. When solving a network device problem, some manufacturers of network devices will want to know what your cabling passed appropriate test. So when we install, we typically have a cable tester that we run to make sure that the cable is up to specifications. Make sure that there's no crosstalk. We make sure that there's no interference in the cabling. And we use a cable tester to do that. So we can document our cabling and we can look at the interference and types of crosstalk that is occurring. When you're calling technical support for a software problem on your server, they're going to want to know what the manufacturer of the server is, and they want to know all of the parts inside of the server. If you ever call Microsoft and want to have support and you have a server that you built, not one that came from Dell, they're probably going to tell you that one part in your server is causing a problem because it's not certified by Dell. So it's good when you're buying servers, things of that type, to spend a little extra money and buy it so that it's certified to work with Windows. We also want to keep documentation for network security. The physical and software security devices, we want to make sure that we have the latest operating systems with the latest patches. We can document that using software. Windows update services, we can use that to tell what operating system computers are running, and also we can run reports of what patches are on there. So keeping that documentation. Sometimes even though we tell a computer to update with the latest patch, it fails, and we might be 2 or 3 patches back on the system and it becomes infected because we didn't have the latest OS patches on there. So what we want to do is make sure that we're documenting when updates get installed, when security patches get installed. What should be documented? So when we're creating this documentation for our equipment and for our network, what do we want to document? This is like the bare minimum things that you need to have documented. One thing we should have documented is a description of the network. So the topology, the technologies that you use in your network, what operating systems you're using, and a number of devices and users that are using the network. We want to have the cable plant documented, so the physical layout of the cabling, what types of terminators or end connectors we used. When we create a labeling for our cables, what conventions are we using? So typically when we lay cables, we put tags on them so that we know where the other end of the cable is connected. So we'll have a convention or a scheme that we use to label our cable and equipment. And then as well as results of any tests that we performed on the cabling. Like I said before, a lot of vendors will want you to test the cabling before they help you try to troubleshoot their network and equipment. We also want to have documentation on where the equipment and telecom rooms are, and what equipment is in each room. We want to know about all of the networking devices. We need to know the switches and the routers, which ports on the switches and routers are used. Part of that is, helps you troubleshoot. If you go in a server room and there's cables going into ports that aren't supposed to be connected, then hey, something's up. Physical and logical addresses. If you see extra MAC addresses on your network that aren't from your equipment, then something's up. Model numbers, the versions of software that you have tested and certified to run on your network. We also want to document our servers. So we're going to document every piece of hardware inside of the server, the OS, the application versions, information about the network card, the serial and model numbers of everything. What we want to be able to do is, if we need to order a replacement part for the server, we do not want to have to shut down the server to open the case to figure out what model we have in the server. We want to be able to have spares on hand. We need to be able to order spares without pulling a server apart and looking at part numbers on the inside of the server. And then our workstation, we need to have our hardware and software configuration documented, and then our addressing again documented for the workstations. We need to be able to identify foreign equipment that is on our network. Once we have our documentation together, we can start the problem-solving process. These are the steps of the problem-solving process. Determine the problem definition and scope. Then we gather information. Then we consider the causes, right? That's called creating a hypothesis, right? So this is basically scientific method. Right? You've seen this before in your science classes. Right? In your chemistry classes, they talk about the scientific process, their scientific method. After we consider what could cause the problem, we devise a solution or a fix. We then implement the solution. Then we test it to find out whether the solution worked or not. Whether it worked or not, we document the solution. And then at the end, we devise preventative measures so that the problem does not happen again. Here is a flow chart of the process. Notice we follow each step. Follow the arrows one by one through the steps in the problem-solving process. After we test the solution, if the problem is not solved, we go back to gathering more information. We consider the causes again. We come up with an alternate hypothesis. We devise a solution. We implement the solution, see if that worked. No. We go through the cycle again. All the while, we're collecting information and we're documenting it in our trouble ticket system. Right? We don't want it to show that we spent 4 hours on the problem and only tried one solution. We want to see we tried this, we tried that, we tried this, we tried that. There may be 4 or 5 things that we tried. We want to see that in the trouble ticket. That way, if we give up and we're not able to solve the problem, when you escalate that trouble ticket up to the next tier, they're going to know what you've tried already. They don't have to start, they don't have to reinvent the wheel because you've already troubleshooted 4 or 5 things before you escalated it up to them. So they like to see that. They like to see, hey, he tried to fix the problem. And again, this is how you're going to get promoted up to the next tier, the IT department. They're going to see your documentation and say, man, look at all the stuff he tried. He knows what he's doing. Even though it didn't get fixed, he did the things that I would have done to try to fix it. After we solve the problem, we're going to document the solution. And then again, we're going to devise measures to stop the problem from happening again. So again, this is going through the steps so we're going to drill down into that process. So determine the problem definition and scope. Okay. One of the most important things that you need to know is the scope, right? You need to know. Hang on, let me switch to my pen. Who and what are affected by the problem? Is it just one computer, or is it the entire floor of employees on their computers? If it's just one computer, I'm not going to go start troubleshooting network equipment because it's not affecting more than one person. The problem is probably on that computer, right? That makes sense. So these are the questions you'll ask to determine the scope. Is anyone near you having the same problem? So you can go around and ask, or you can ask the person, have they asked other people if they're having the problem? What about other areas of the building? It might just not be this floor. It might be different departments. It might be multiple departments. If that's the case, then we need to go higher and higher into the network, right? Maybe to a router instead of just a switch if it's affecting that many people. On the person's computer, once you narrow it down maybe to their computer, is the problem occurring with one application or all of them? So they say, I can't print. Well, can you print from Excel as well as Word? So they complain, I can't print from Word. Well, will Excel print? If they go and print from Excel, then you say, oh, it must be a problem just with Word. If they can't print from Excel either, maybe you can try printing from a browser to see if it's just Microsoft applications. So that's one of your troubleshooting techniques, is to scope the problem on the workstation also. If you move to a different computer, does a problem occur there as well? So maybe you have them log on with their account at another computer to see if it's their account. So what we're doing is we're taking different pieces and swapping them out. The computer, the application, the person. We're swapping out different things that are in our problem to figure out which one has an effect on whether the problem gets fixed or not. All right? So just like when you're trying to fix a computer, what you do is you start swapping out pieces, trying to figure out which piece is having the problem. When you swap out the piece that was the problem, the computer will start working again. So that's what we're trying to do. We're trying to swap out, change different variables to try to get the problem fixed. All right, so here's some examples. So think about these. Mike can't access the email server. Okay, so Mike, email server. Other servers are available to Mike. So other servers are working. They're okay. And no one else reports the problem. So where do you think the scope of the problem might be? When you scope the problem, it's probably Mike's account and it's just on this email server. Since Mike can log into other servers with no problem, and no one else is having the problem, it's probably that one account on that one server. The third floor users can't log into the network. Other floors can. So think about that for a second. Where do you think that problem would be? Would it be on a single computer? Probably not, right? Since it's the entire floor that can't log in. What we might try to do is troubleshoot the switch in the telecommunications closet. If all of the users on the third floor use the same switch, then we can start there with the scope of the problem and narrow it down. Camille can't print to the new LaserJet printer on her fourth floor. She has tried several applications, so it's not just one application she's having a problem with. No other users have tried to print to this printer. So what do you think the scope of the problem might be? Since we're lacking information, what we might try to do is go to the next door neighbor and see if the next door neighbor has printed to it, if it works. If the next door neighbors can't print to it either, I would look at the LaserJet printer rather than the user. If no other users have printed to it and she can't print to it, I might ask, have they ever been able to print to it? Right? It says it's a new LaserJet printer, which probably means if there's a problem with it, maybe we haven't discovered it yet. Right? So we might say, so you're like a detective. You take in all of these little pieces of information, you do a little bit more investigation, and then you try to start working through in your head, what is the most probable cause of the problem? All right. You also have the fourth floor thrown into this. So you can try that also. Try from another floor. Okay. Julie reports that the network is slow while accessing her documents folder. Access to the internet and other resources seem to work with normal performance. So Julie is having problems accessing the documents folder. And it's not that it doesn't work at all. It is that the performance is slow. This one is more difficult to troubleshoot because we have people's perceptions in play here. It might just be Julie. She might be in a rush today, and she's got a lot of deadlines, so she thinks everything is running slow because she's trying to work faster, right? And it's very difficult for a network administrator or a server administrator to prove that something is not slow, right? Because, again, it's all about users' perception. It would be good to have documentation here of the network, maybe have a baseline of how long it typically takes somebody to access the documents folder. If we have a baseline when it's working normally, we can compare it to what's going on now, and then we can actually see whether it's going slow or not, slower than it was when it was working normally. Okay. We can also ask other users, hey, have you noticed that the documents folder's been responding slowly? If it is other users, a bunch of different users, maybe we want to talk about adding server power or adding another server to handle all the requests. It might become the documents folder might be becoming overloaded, right? So we can also look at the hiring. Maybe we hired another 100 people in the department or the organization, and that's what's causing it. Right? Once we define the problem, the scope of the problem, and the definition, then we're going to assign a priority to it. Typically, we're not going to solve one problem at a time. We're going to have multiple service tickets. So we're going to assign a priority to the problem. And how do you assign a priority? Typically, what I do is the larger scope of the problem, the more people it's affecting, the higher the priority. If you're in a smaller company where you have like a sole proprietorship, where you have the owner of the company on the network, maybe that might affect your priorities. Maybe the owner of the company always needs to have the fastest access. So you have politics and stuff like that going on. But typically, if it's a large organization, your priority is going to be based on how many people are affected by the outage. Once we write down what the problem is, so we've documented this is the problem, and we've scoped the problem, we say these are the people that are affected by that problem, we ask these other questions. Did the system ever work? Right? Like that new printer we talked about. Did that printer ever work? If it never worked, it's probably the printer. You can ask them when it stopped working. Does the problem occur every time you try, or does it work half the time? Right? So they're printing, and every other time they try to print, it doesn't work. Are there particular times in the day when a problem occurs? Are other applications running when the problem occurs? So you might need to write down these questions when you first start working in IT so that you remember what to ask. As you become more seasoned, you'll remember these questions and they'll come naturally and you'll just start asking them. But when you first start working as IT support personnel, you're going to want to have a checklist. And people that go work for the police department, detectives, they have little notebooks like this that have questions. Forensic investigators have checklists of what to ask and what to do. So it's not embarrassing to carry around a list of questions to help you remind you how to troubleshoot until you become more accustomed to it. Has anything changed? Ask yourself the question as well, were any changes made? Well, how would you know if there's any changes made? You would go back to the change management program in your organization, if you have one. If you don't have a change management procedure, it's going to be more difficult to tell if anything has changed. A lot of times the end user has done something, and maybe they don't want to tell you that they changed, right? So maybe they installed a card game, or maybe they installed an instant messenger client, and it stopped working after that. The end user's probably not going to tell you what they did right before things stopped working. Okay? When you're working with a computer, things don't just happen. There's always a cause to what is malfunctioning. And sometimes, like I said, the end user will not tell you or lie about what they have done. And it makes your job harder. Okay? That's why it's important for you to build trust with your clients so that when they do something like that, that they don't feel like you're the computer police. Right? So, if you have a good rapport with those employees or your customers, they're going to say, hey, I know I shouldn't have installed this instant messenger client, but I was trying it out. And they tell you that, and you say, well, this is why we tell you not to do it. Please don't do it again. And then it's real easy to fix the problem because they told you, instead of you spending hours to come to the same conclusion and figure out that they changed something that they shouldn't have. Right? So remember, you don't want people viewing you, the IT department, as the computer police. You want to have a good relationship with your clients. Don't overlook obvious things, like has somebody kicked a cable and knocked it out the wall? Has somebody pushed a button or done something like that? So always check to make sure the computer's on, make sure the monitor's on, things of that nature. Have a good idea how it's supposed to work, right? That's called the baseline. So if you have a baseline of your network and statistics, then you should be able to tell whether the data is moving slowly over your network or not. If I don't have a good definition of how the network is supposed to work, how the throughput of the network, then I'm not going to be able to troubleshoot it as well. So again, this would be preventative stuff that we would have to do. We would have to take a snapshot of the network to create a baseline when the network was working normally. Consider the possible causes. Your goal in this step is to create a checklist of possible things that could have gone wrong. Right? So you come up with 4 or 5 things. Right? Here's an example. An entire area of the building lost connection with the network, but no other areas are affected. So you have one floor or an area of a building. Right? So you start thinking, what could have affected the entire area of the building? So you start thinking the connection in the main wiring closet has failed. The switch to which all workstations are connected has lost power or failed. All the workstations have acquired a virus. A major upgrade has been made recently to all the workstations, and incorrect network addresses were configured. So you came up with 4 possible causes. Once you do that, you start ranking these on the probability, right? The most probable thing is probably you have a bad configuration with the upgrade. Okay? The second most probable thing is there's a virus on the network. These network equipments that you have, the connections and the switches, are typically redundant. They have multiple power supplies, things of that nature. So typically I would check those last. They're created to run for years and years and years without any problem. So I would check the workstations and the OS configurations before I started checking anything else. Once you decide on what is causing the problem, how should you fix it? Right. Is the identified cause of the problem truly the cause or just another symptom? Is there a way to test the proposed solution adequately? What results should the proposed solution produce? So we want to know what success looks like before we test a solution. What are the ramifications of the proposed solution for the rest of the network? If we replace the switch, if it's a switch that has gone bad, if we replace the switch, are there any other departments that'll be down while we're replacing the switch? Does that make sense? Do you need additional help to answer some of the questions? Maybe you need to ask somebody at a higher tier how something should operate. All of those things you need to ask before you plan your solution. Again, also, you want to make sure that if the solution causes data loss, that you don't, or connection loss, you don't want to implement that solution without talking to other people. So you might need to do this after you might need to do these things following when you devise your solution that you want to use to take action upon. Save all the configuration files before you start changing them. Document and backup workstation configurations. Document the wiring in the closet configurations. A lot of times what I'll do is I'll get my cell phone out and just take a picture of the wiring. Once you start making changes and implementing fixes and they don't work, you're probably breaking the system further. So what you want to do is, if you implement the solution and it doesn't fix your problem, you want to return everything back to its original state. Does that make sense? So if I unplug wiring and change wiring in the wiring closet and my fix does not work, I want to put those wires back. If you don't, you may find yourself trying to fix a compound problem where you have layers and layers and layers of things that you have done to try to fix it, and you've broken the network further. Right? So we always want to restore what we changed if the solution doesn't work. Go ahead and implement the solution. So implement your fix. Test using small steps. Change one thing at a time. Okay? So you make one change, test it. Make another change, test it. So we don't want to change multiple inputs, multiple variables at the same time. That makes troubleshooting more difficult. Make sure your users are informed on what's going on. And then put your plan into action. Make notes about every action you take, right? Because that's going to go back into the change management so that we can update our documentation. If we had to replace the switch, then we need to document the new switch serial number and the switch model, things of that nature. So we want to make notes about everything that we do. Test the solution. For instance, if you're testing a workstation problem, attempt to log into the network as a user with similar privileges as the main user that's having the problem. Next, attempt to access applications that would be run from that workstation. If testing a network upgrade, start some workstations on the upgraded part of the network and run some network-intensive applications. So what we're going to do is have a control group where we don't change anything, and then we have a test group where we're changing the settings to see if it fixes. Gather information about how the network behaves and compare it to the previous results. So this is testing the solution to see whether it worked or not. Document the solution. Your documentation should include everything pertinent to the problem. The definition that you created, the solution that you proposed, what happened when you implemented the solution, and how you tested it to make sure it worked correctly. If the problem and its solution have implications for the entire network, include this in the information. So if while implementing this fix there was a downtime of the network, you want to put that in your solution also in the help desk. Step 8, devise preventative measures. Once you figure out what caused the problem, then we're going to say, from now on, we're going to do this instead of this, and that'll stop this from happening again. An example was, if your problem was a virus that spread through the network, we're going to install anti-malware, or maybe turn up the filter, the spam filter for our email software. So we're actually going to take measures to make sure it doesn't happen again. That makes you, instead of being a firefighter, you're going to be a fire preventer. So you're not going to be running around trying to fix problems after something is broken. You're going to fix the problem before it occurs so that there's no downtime. Okay? So we've been here for about 50 minutes. Go ahead and take a 10-minute break and give your brain a chance to rest, and then we'll continue. We're about halfway through the slide presentation. Okay, we're back. You should have gone and got a drink and went to the bathroom, those types of things. Like I said, give your brain a rest, and we'll continue on now. There's different approaches to network troubleshooting. So we're troubleshooting a network. There's different methods that people use. To give you some idea of the different methods people use, here we're going to go over them. You need to choose which one that makes most sense to you, that works for you. The first type of troubleshooting is trial and error. It requires an assessment of the problem and an educated guess to a solution and a test of the results. So we should use trial and error under the following conditions. The system is being newly configured, no data can be lost, right? Because we're going to be doing just trying different things. There's not a lot of experience needed for trial and error. You're just pulling pieces out and put them back in. Again, this wouldn't work good on a network that's full of users or data. The system is not attached to the live network. You can undo changes easily. Other approaches would take more time than a few trial and error attempts. So trial and error method is fast. There are a few possible causes of the problem. No documentation and other resources are available to draw on to arrive at a solution more scientifically. So if you walk into some place and they ask you to troubleshoot and you don't have any documentation, trial and error probably be the best, because you have no idea what the system looks like anyway. So you say, it's probably this and try it. And then you say it's probably this and try that. It becomes expensive because you have to buy all that equipment to replace the equipment that you're swapping out. So it becomes expensive, but it's very quick, the trial and error method. You should not use the trial and error method under the following conditions. A server or device is live on the network. The problem is being discussed over the phone and you're instructing an untrained user. Right? So this is something for you to do, not to pass to someone else advice to someone else over a phone. You aren't sure the consequences of the solutions you propose. You have no sure way to undo the changes after they're made. Other approaches will take the same amount of time. So if one of the other approaches will take the same amount of time, the typical advantage of trial and error is the speed in which you get things fixed. But if the other methods take the same amount of time, then you'll probably want to use one of the other methods. Trial and error can really impact the network and impact your data. When you're using this method, make only one change at a time before testing the results. Avoid making changes that might affect the operation of a live network. Document the original settings of hardware and software before making changes. Like I said, maybe use your cell phone camera to take a picture of screenshots or wiring. Avoid making a change that can destroy the user data. If possible, avoid making a change that you can't undo. You must be careful to not make the matters worse if your proposed solution can affect other systems or cause data loss. So again, you don't want to make the problem worse. Solving by example is a process of comparing something that doesn't work with something that does. So if you have two switches that are in the network and one is working and one is not, look at the configuration of the switch that is working and try to find differences in the two configurations for the switches. Solving by example is one of the easiest and fastest ways to solve a problem. Rules to follow when you're using solving by example. Use it only when the working sample has a similar environment as the problem machine. Sometimes we have test labs for this. Maybe we have a section of the network that's not connected to the rest of the network, and we have the same equipment and the same layout of the network. We can test it in that trial network before we put it into production. Don't make configuration changes that will cause conflicts. For example, don't change the IP address of a non-working machine to the same address as the working machine. So when we see the working switch, we don't want to use the same exact settings of the working switch, because some of them should be repeated, such as the switch's IP address. Don't make any changes that could destroy the data that can't be restored. That would be like customer records, purchases, things of that nature. The replacement method requires a narrowing down of possible sources of the problem and having known working replacement parts on hand so that can be swapped out. So this is like the trial and error, but we're going to be pulling out parts and replacing parts. Follow the rules. Narrow the list of potentially defective parts down to a few possibilities. Make sure that you have the correct replacements on hand. Replace only one part at a time. If your first replacement does not fix, reinstall the original part before replacing another part. Again, this is the method I use when I have a system that won't boot, that won't post. So I've got a computer, and I turn on the computer, and I don't get any error beep codes. I don't get any error messages. It doesn't even initialize the monitor to show me anything. When I'm working on a workstation like that, and I have no information at all about what can be broken in the system, what I typically do is start pulling parts out of the system and replacing them. The last method is the step-by-step with the OSI model. In this approach, you test the problem starting at the application layer and keep testing each layer until you successfully test and reach the physical layer. Typically with this method, I start at the physical layer. I don't start at the application layer, but whatever way that you feel comfortable with, you go through the OSI model and you say, is there a problem with the application? Is there a problem with the IP address at the network layer? Is there a problem with the MAC address? And then is there a wiring problem? Okay. This is the most complicated approach. You have to understand how the networks work and where you should use each troubleshooting tool. We have all kinds of tools to troubleshoot the OSI model with, but we need understanding of how things work to use the OSI model or conceptual model to try to fix the problem. So here's an example of knowing which layer each device is part of. So the workstation would be all layers. The cable would be this physical layer. This switch would be layer 2, or the data link layer. The router would be the network layer, the data link layer, and the physical layer. Right. So we look at all these devices and we use the OSI model to order our steps in our solution. You're not always expected to know everything. Okay. People that have degrees in IT from 10 years ago may not have the information about the latest changes in the operating system or the latest changes in the iOS for the routers and switches. So you need to know where to go to find help. Okay. Here are some resources that are available to you during your troubleshooting process. You have your experience, and you can draw on your experience from previous troubleshooting sessions. You also have the experience of other people in the IT department, so don't forget about that. You have the internet, and then you have your documentation. So always remember that you have other resources that you can go to outside of your brain to help you troubleshoot. You're probably not the first person to run into the problem. It's rare that you're the first person to run into a problem in the Windows operating system. Okay. Experience is your most effective weapon, because you don't have to go down the hall. You don't have to go out on the internet. That's part of your experience and your problem-solving tools inside of your brain. The way that you can maximize using your experience as a troubleshooting tool is to make sure that we document what we have learned and seen. And if you've written it down, you can go back through your notes. You can go through previous troubleshooting tickets. You can do keyword searches on troubleshooting tickets. So if you're having a problem with Microsoft Word, go in the help desk system and type in Microsoft Word and see trouble tickets that people have had with Word before to see if anybody's already fixed it. If it happened once, it'll happen again. Don't think that a problem is so weird that it'll never happen again or that nobody's ever run into it. Remember to use your colleagues, the people you know, as a resource. And also go to the manufacturer's technical support. So you can call their 800 number. And if you have very specific information about the problem, such as a stop error message or an error number, you can report it to the manufacturer and they will tell you what is the most likely cause of the problem. We also have the internet. We can go to the support.microsoft.com or support.dell.com, and typically they have something called a knowledge base, which is a database of every problem that people have troubleshooted before. So what you want to do is go through there and do a search. Like I said, you're probably not the first person that has run into that problem. When you type in error messages into these search engines, make sure you put quotation marks around them. That makes sure that the error message is searched for as a phrase instead of just separate words. Okay? Be as specific as possible. If you're having problems with a printer, don't just type printer. Type printer cannot print or toner, or be as specific as possible with your search terms. Drivers and updates. Go to the website and check whether there are some updates to the drivers that you're using or updates to the operating system that you're using. Most of the time, updating a driver will fix a problem with a piece of hardware. We have online support services. Some examples might be, see if I can remember the name of it. It's like these online communities that you go to. And you go to the website and experts exchange, like it says on the slide. There's also another one called Spiceworks. Go to that website, TechNet forums, and you can talk with people and they'll give you their opinion. And typically, if you participate in those forums, there's some kind of reward system where you get medals or, notoriety for helping people fix their problems. We should use our network documentation. Okay, your network diagram should include diagrams showing a logical picture of the network and then the physical network. Here's a logical diagram. Notice it doesn't really tell us where these computers are located. It tells us how they're logically connected and their addressing. Okay? So it tells you what network addresses you have, tells you the connectivity devices, tells you the network numbers and how they connect to the internet. So this is a logical network diagram. See, these are the same computers as the next slide, but this is a physical network diagram. Notice it shows us all of the wires and how they're wired together. So we need a diagram of how they're logically connected and then how they're physically connected. Remember always to document your internet networking devices, your switches and your routers. Typically what I do is I just copy the running configuration from the routers and I save them to a text document. And then I do that at least once a year, maybe more often. Every time I make a change, I make a copy of the running configuration so I can change it back if I need to. Here's an example of some documentation of the networking equipment. Now we're going to talk about some tools that are built into operating system that we can easily test a network with. The ping command tells you whether your computer can communicate with another computer. So you run ping, and then you type in the IP address, and then it'll tell you whether it's working or not. If ping doesn't work, then none of the other applications on your computer are going to work. So ping is a good place to start. We can also use ping to test the throughput, how fast the network is working. It'll tell you RTT or response times. It'll tell you how long it takes for the message to come back from the computer you're pinging. It allows us to test the throughput in a network. Traceroute is another utility we can use. Hang on. There's also extra options you can use with ping. Okay. You can ping your loopback address that tests the IP networking stack on your computer to test if TCP/IP is installed correctly. And then I can ping an IP address that's on the same switch as me. And then I can ping the default gateway or the closest router interface. And then I ping an IP address of a host on the internet. So I start out small and I keep pinging to see how far out I can ping. It'll help you to locate where the problem in the network is. You can ping the name of the IP address that will test your DNS servers. You can ping the actual DNS servers themselves and use NSLookup to tell whether the problem is DNS. Remember, DNS is the phone book service that translates names into IP addresses. If DNS is not working, it may look like it's a networking problem, and it's not a networking problem. It might just be a problem with the DNS lookup service where it's not translating the names into the IP addresses. Traceroute does a reverse DNS lookup on the IP address for each router and displays the name of the router. So it pings each router in between you and the destination and tells you whether the router is online and whether or not it's responding very quickly. I can tell easily which router in between us is responding slowly by using the traceroute command. Typically, traceroute does not work on routers out on the internet. It would just work within your own network. Most routers block ICMP or the ping command because of firewalls, and you're not going to be able to use traceroute command on the internet. But if I'm using it inside of my own organization, I should get information like this. So when I'm tracing my route to a web server called books.tomshow.com, here's the IP address that I'm trace routing to. It says this is my gateway, and then there's other routers that I pass through in between, and then finally I get a response back from the router at the destination, or the server at the destination. So when I communicate with this particular IP address, these are all of the routers I'm going through. Okay? And these are the response times. So if we look here, this response time is kind of high. So if we're trying to find a bottleneck or the slow part of our network, we can use these times to figure out which router is operating slowly. We can also have network monitors. It's a piece of software that can track the network. They can track your packets, errors, and traffic from and to each computer. So if you notice that your network is running slow, it might be because one of your computers is using Netflix or something, using up all your bandwidth. These network monitors will help you to locate that computer. Protocol analyzers allows you to capture the packets that cross the network and look into them and analyze them. An example might be I'm using Wireshark and I'm looking on the network, and people are sending out requests for IP addresses using DHCP and nothing is responding. So that might be an example. We can also use TDRs, or time domain reflectometers, and they can tell me whether there is a break in a fiber optic cable. Um, it also it reflects it measures the time it takes the signal, the light, or the electrical impulse to travel down the line and come back. It tells me how far away the break is. So it'll say the break in your cable is 10 feet away from the end or 20 feet from the end. You can also document the length of your cable. Remember, there is maximum cable lengths with different protocols or standards. For a patch cable, the maximum length of your patch cable should be 10 meters. The wire in the wall that goes from your port to the telecommunications closet should be at maximum 90 meters. So we can use these pieces of equipment to tell whether we're falling within those standards or not. We can tell cable lengths. We can also get cable testers. They can test whether the wiring is correct inside of the cable. They're great for checking patch cables to make sure that the cables are wired correctly. The basic cable testers cannot check for attenuation. Attenuation is signal loss. Cannot check for crosstalk. That's signals impeding the signals that are coming into a wire from another wire. It cannot test for noise or other performance problems. There are some more expensive cable testers, such as Fluke cable testers. They can cost several $1,000s, and they'll do all of these tests. They can test for crosstalk, attenuation, problems with interference. They can tell you if the wiring is wrong. So there's cable testers that do everything, and they're really expensive. The one we have at the school can also save and export the test to Excel, so we can have a documentation of us testing the wires. Getting down to inside of the actual physical wiring, we can use multimeters to test the voltage, current, and resistance on a wire. We can use tone generators to trace wires through buildings. An optical power meter is used to measure the amount of light on a fiber optic circuit, so we can tell whether the fiber optic circuit is too long or if it's losing signal. So here's some common troubleshooting situations that you might run into. If you run into cabling and related components, your first step is going to be to determine whether the problem is with the cable or the computer. So we're going to make sure that it's connected to the computer properly, the cable. Look at the NIC lights on the back. You should have like a green light or a green blinking light. That's a physical link light. If your NIC doesn't have any lights, you can try swapping out the NICs. You can try swapping out the patch cable. So this is like the physical layer thing. So if you start at the physical layer troubleshooting, you should look at the cabling first. Power fluctuations. Okay? Are you having brownouts, or is the computer rebooting because it doesn't have enough electricity? Is the switch or the router? One of the ways that you can troubleshoot power fluctuations is to install UPSs so that the computer doesn't just turn off or have its power pulled from it. It'll shut down correctly. All right. So you should have these UPSs installed on your networking equipment so that we don't have corruption on the network. Remember, when you do an upgrade, sometimes upgrades break things. Keep current and do one upgrade at a time to make your life easier. So we want to make sure that we're doing keeping all of our patches up to date, and do one at a time. So approve one update, let the update go out, verify the update has been completed, and then start the next update. Always test your update before deploying it on your production computers. and make sure that you're telling your users you're doing upgrades. They'll be more understanding if they start having problems, if you've notified them, hey, we're upgrading something. So when you're having performance problems, these questions should help you out. What has changed since the last time the network functioned normally? Has new equipment been added to the network? Have new applications been added to the network? Is someone playing electronic games across the network? Or like I said, watching Netflix or videos? Are there new users on the network? Can any other new equipment, such as a generator, cause interference near the network? So typically, it's something that has changed. That is why we keep this change management going, because it's a lot easier to troubleshoot if we have the list of changes that we've made. We need to have disaster recovery in place. Disaster recovery is how we go about recovering from a failure of a server or a piece of equipment. We need to have that plan in place so that we know what we're going to do ahead of time, and maybe even have spares on hand. So disaster can be anything from a server disk crash to a fire or a flood. So if we have a flood, the equipment gets wet, what do we do to replace that? We need to have that plan in place before the disaster occurs. So we're going to talk about backup procedures and recovery, how to recover from a failure. So when you first start talking about backup, it seems like it's a pretty easy thing. You just make copies of your files, right? Well, it gets really, really complicated with some of these different factors that we need to look at when we're doing our backups. Okay? We need to determine what data should be backed up and how often. Remember, the more data you back up, the more often you back up the data, the more it costs. So we didn't want to spend extra money backing up the installation files for Microsoft Office. We just want to back up data that's non-replaceable. Right? We need to develop a schedule for backing up our data. Remember, the more often we back up our data, the more expensive the backup is, the more tapes we're going to have. We need to have the person that the buck stops at, right? The person responsible for performing backups. If there's not a person that has backups written in their job description, if they don't know that they're responsible and they're the person that is going to get reprimanded if the backups don't get done. If we don't have that responsibility with one person, the backups are not going to get done. You need to make sure that one person is responsible for ensuring that the backups are done. We also need to make sure that we test our backup system regularly. That means taking the backup and restoring some files off of it. Even trying to restore the entire server. A lot of times people think they're backing up their server and they're not. Maintain a backup log listing what data was backed up, when the backup took place, who performed the backup, and what media was used. We need to be able to find that stuff in case of a disaster. And then develop a plan for storing the data after it's been backed up. How are we going to transport the backup tapes to an off-site location? Remember, we don't want to keep our backups in the same building as the server. If the entire building catches fire and burns down, then our primary data and our backup are going to get melted or destroyed. So we need to have the tapes taken to an off-site location so that we can store it. Remember, the backups have all of our files on it for security purposes, so we need to make sure that it is secure and people can't have access to it and get files off of it. It doesn't matter what kind of security precautions you take to protect your server and your physical server room. If somebody can get your backup tapes, you've wasted all of your money. So we need to have a plan on how to transport backup tapes and where to transport it where to store it securely. So here's some terms you'll hear when we talk about backup types. We'll have full backups. It copies all of the files and marks the files as backed up. They take the most amount of time to perform a full backup. They take up the most space. But to restore them takes the least amount of time. So full backup, most space, most time to back up, the least amount of time to actually restore them back in case of a disaster. An incremental backup copies all the files that have changed since the last full. So what we'll do is we have Monday through Friday. Remember, there's a balance between cost and the amount of time that has passed since the last backup. We need to balance those. So here's our calendar. We might do a full backup on Monday and then do incrementals the rest of the week. So we have all the files on our server on the Monday backup. And then on the rest of the week, during the rest of the week, we do backups, but we only back up the files that have changed since the last full or incremental. Okay. So if I have this schedule, on Monday I back up everything. On Tuesday I back up everything since the last full backup. On Wednesday I back up everything that's changed since the last incremental backup. So I have a day's worth of changes on this tape backup. And then on Thursday, I have all the changes that I made between Wednesday and Thursday. And then on Friday, I have all the changes that I've made since Thursday and Friday. So to restore this backup, I need to restore the full backup first, and then I need to do 4 more restore jobs. Okay. Incremental backups take the least amount of tape space. They take the least amount of time to do backups. They take the most amount of time to do a restore. So when you're actually trying to get your data back, you're going to have to do 5 restore jobs, which takes the most amount of time. If I was just using full backups every day, I would just do 1 restore job, right? So let me clear this off again. If I was doing fulls every day, so this is Monday, Tuesday, Wednesday, Thursday, and Friday. You see how this gets complicated? So if we're doing fulls every day, that means I have a full copy of all of my data every day. It's going to be really expensive because I got to buy a lot of tapes, and it's going to take the most amount of time. Why do I care about the time it takes to do a backup? The reason I care is because nobody can be on the system. The system needs to be quiet when I do backups. A file that is in use cannot be backed up. So I have to kick everybody off the system while I'm doing backups. So if the a full backup takes 6 hours, I need to take my servers offline for 6 hours. That might not be acceptable. So what we would do is maybe do an incremental backup. It doesn't take as long. All right. The last case is incremental or differential backups. With differential backups, I do a full backup on Monday, and then I do differentials on the rest of the days. Remember, the full backup is going to have all my files. The differential is going to have all of the files that have been changed since the last full. Okay. So Wednesdays are going to have all of the files that have changed from Monday to Wednesday. Whereas the incrementals were backing up anything that's changed in a single day, these differentials back up what has changed since the last full. So on Thursday's differential, I have all of the files that have changed since Monday. And then Friday, I have all of the files that have changed since Monday. When I do a restore job, I have to restore the full backup and then the last differential. I do not have to restore these because I have all the files that have changed since then. This is kind of the middle. middle ground between incrementals and fulls. Differential backups are the middle between the amount of files you need to back up and the time. And then it is the middle with the amount of time it takes to restore. So that's kind of a middle ground. A copy backup copies the selected files. So what you do is you go onto the server and you check the files that you want to back up, and it just copies those files. Right? It doesn't take a backup of the whole system. A daily backup is just all of the files that have changed the day the backup is made, but it doesn't change any of the files to let them know that it's been backed up. A bare metal restore backup has all of your backups in the backup, all of the files that you have on your server in the backup, plus the Windows installation files, so that it can actually install the OS and the backup software on the system and then do the restore job. So we're not going to need any other disk with a bare metal restore backup. Of all of these backup types, the full, incremental, and differential backups are the most useful as part of a regular backup schedule. A good model for creating a backup schedule combines weekly full backups, like we said, a full backup on Monday, and a daily differential. When creating a backup schedule, post a schedule and assign one person to perform the backups and sign off on them. So they're going to sign every day when they do the backups. If you don't have that, you're not going to have backups. Windows systems have additional backup called a system state backup that copies the Active Directory. All right, you need to make sure that you back up the system state also. If not, you won't have a backup of the user accounts and passwords. If you back up the tape media, make sure you can restore data. Right? Use the verify data option. So you back it up and then it goes and reads all of the data back during the backup to make sure that it was copied correctly. When we talk about disaster recovery plans, we're talking about coming back after a disaster, how to get the parts and pieces of the computers back in the working state. A business continuity plan is a little different. It says what we're going to do to continue business while the disaster is occurring. So until we can get the servers back up with the disaster recovery plan, the business continuity says how we're going to do business while things are being fixed. Okay? Because we want to continue to be able to do business. Some of the things we might put into place for business continuity is to have a coal site. Coal site is a physical location. It houses the hardware needed to get the IT functioning again. So the coal site might just be a building. Right? It has the computers, but it doesn't have electricity turned on. It doesn't have a copy of the data. It takes a little while to get it started. Right? So it might take a couple of days to get a coal site started. A warm site is a location containing all of the infrastructure needed for operations to continue. Okay? So a warm site might have to restore the daily backup, and the electricity's on, the computers are ready to go. Your employees just need to move to that other site. A warm site is more expensive because you have to keep the utilities turned on. So a warm site might take a day to get back up. A hot site is a location that can be running at a moment's notice. Right? So you have all your people duplicated, you have all your computers duplicated, all of your data duplicated. You don't even notice that the primary site went down. Hot site has a full-time connection with the original site so that the data is synchronized and up to date. We don't have to do any restores with a hot site. Hot site is most expensive. Warm site is kind of the middle ground, and cold site is the least expensive, but takes the longest to get working. And that is the end of the chapter. It was a pretty long chapter, but these things are things that the certification exams always ask you about. The disaster recovery plan, business continuity plan. If you don't have these plans in place, then I think think they say about 80% of businesses go out of business after a disaster like a fire. So we need to make sure we have all this documentation, all of these business continuity plans and disaster recovery plans in place for our business to thrive and be able to continue to do business even after we've had some kind of malfunction or disaster. Thank you for joining me today for this lecture, and I hope it helped you understand the chapter a lot better.